Yes, this is live push from Permaculture Farmers, and I want to tell you something about why we make compost. As we can see here, this is the reason we make compost. And in any farming, we need this cycle here, which is saying soil, plants, animals. And the reason we make compost is that we don't have that circle in many farms nowadays. So let's move on and see what's going on. So here's some of my compost, just different kinds, so just to give you an idea of what I'm actually talking about. Yeah, there's a number of ways to make compost. This is what we call vermiculture with earthworms, and this one is actually with has been made with this called thermophilic compost, and this one is also from last year, earthworms thing. So this one, the worms will migrate from, which is this one here, over to this one. So they're all been taken up by vermi compost from at the end. So this is how it looks. And the compost we make is not just compost. Most compost you can get, or people are making themselves, is what we call reduced biomass, which means it does not have this biological requirement for biocomplete. So the compost I make and I tell people to make has this biocomplete, and that means that we have a certain bacterial biomass. This is 135 microgram per gram of compost. Fungal biomass is 135 microgram per gram of compost again. And very important here, we have what we call FB ratio, fungus bacteria ratio, that is equal to or greater than 0.3 to 1. So this is a minimum, 0.3 to 1. And then we have the protozoans, which we know are many different small animals in the soil, and this is 10,000 per gram of compost. The beneficial nematodes, 100 per gram. Ciliates must be 5 per gram in a 1 to 5 dilution, as we got. And this is all something we look out and see in a microscope. When we make the compost, we test if it is not living up to this criteria. It is possible to make further amendments that's designed to live up to this criteria. So if we make the different kind of biocomplete liquids or biocomplete amendments, where the most common ones is a compost extract or a compost tea, which are two rather different things. They have to live up to exactly the same requirements. This is very, very important. This is the difference between just bringing out some reduced biomass and the whole soil food web, because this is what we look at here, is the whole soil food web. Next, here we have a picture of what is inside. You can see we have a biomass for bacteria here on 1800. This is a test taken out, so we can see what's inside. Fungal biomass is 3,000. You can see the FB ratio is 169. This means it's one bacteria and 169 in fungus, which we can also see when we look here. We have a biomass which is 3,000, and here we have a biomass which is 1,800. So obviously, and this is why we have 1.69 to 1, which is very good. And we have the different numbers here. If we take the total here, we want to see, can we find the protozoas that are here? And you see this is 1.8 million in numbers per gram in this test here, in this soil compost sample. I can tell you it's compost. Flagellates is almost is over half of them. Then there's flagellates standard deviation, but only 9%. Quite a big number, but only 9%. Amoeba, we know the amoebas, many different kinds, and there's also 800,000. You can see when you look at this one, flagellates and amoeba, we have almost the whole thing. The interesting thing with this protozoa is what they're doing is eating bacteria, and they eat something like 10,000 bacteria a day, each one of them. And that means that when they eat all these bacteria, then nutrition fertilizers are made available to the plants. And this is what the whole point is in having the soil food net food completed. The rest follows the same standard. We have some interesting thing here, bacterial nematodes. The nematodes are also eating. They might eat up to 30,000 in a day. Fungal feeding nematodes, 200 a day. They're not necessarily what we want so much, but still fungal feeding. They also eat fungus. This is the other big biomass in the soil. So they eat the fungus and again make a lot of fertilizers available in that. And then they have predatory nematodes. We like them. There's nobody. And the predatory nematodes are actually eating root-feeding nematodes, first of all. Humus, these are disease fungus in the soil. And you see it's there. It's not a lot. This is a very, very good compost, so it doesn't have much of it. Ciliates means that we have, it's also a protozoa, but it means that we have what we call anaerobic conditions or facultative conditions, sort of low level oxygen in the soil. But they are still very beneficial. They eat also a lot of bacteria, more than 10,000. Well, here comes, in fact, the root-feeding nematodes, and there is none of them. This is the reason for that here. This is the dementorial microorganisms. Those are the ones which are not necessarily what we really want to see. The reason for we don't want to see them is, first of all, that they are an indicator that the soil is anaerobe, which means there's no oxygen for the roots of the plants. Next is here. This is what we are starting with. This is a picture probably from Denmark, and it will. This is how our soil looks: sand dune with nothing at all, and it is really down to sand, silt, and clay inside here. All organic matter, which has been tree. This looks a little bit like a clay soil here. It has been 3.5. For our sandy soils, it's 4 to 4.5. All of this is now down to 1%, and it is nearly turning into a complete desert soil. The only way you can grow this soil here, unless you use this regenerative methods, the only way you can grow it is really by plowing, harrowing, sowing, spraying, and all of these different things that we do in the conventional farming. There's a high input growing, and this is also quite common that you grow a crop here where you don't make any money at all. Even the energy balance can be negative, so you put more energy into it than what comes out of it. So it's a bit of a joke. So the solution is to make this compost tea, compost extract, the biological methods. And here you can see a plot over here, which is going up and down. It has not been treated with biocomplete compost or biocomplete products of any kind. This one have. There is a reduction on 95% of weeds just by spraying. And this might be making anyone think, okay, how does that happen? And this is what I want to explain now. So here it is. We have the soil biology succession causes plant succession. So here, this is what we have when we talk about conventional farming, where we are plowing. and harrowing the soil. So this is what we have. We are right here in this thing with nothing, or desert, basically desert with nothing. And then if we move on, we get into this succession, which eventually end up with old forests, which are very, very productive, of course. So this moves also from bacteria, few fungi, balance, more fungus. And in the numbers, it looks like this. Bacteria is the only thing we have when we're here. When we move a little bit to the other side, we get a little bit of fungus, but still it's 0.1 to 1. And we know it was supposed to be 0.3 at least, okay? And here you can see we have, we started to get a balanced thing. And where we really want to be is here in a 1-to-1 situation, or even further for some crop. So this is the area where we would like to work in. So 0.5 to 1 is really what we have here again. Further over is very good, but it is more for it, or it is maybe first of all for perennial crops, which will then be more productive. So what we get out of it, and the reason for that we get rid of the weeds, is that the weeds, most weeds we have is the seed weeds, which comes up every year. It is based on nitrate or NO3. And if that is not in the soil, they don't grow so much. They grow much less. So as we move this one here towards more fungus, we get over to what's called ammonium, NH4, which means that the weeds are not coming, because these are not the conditions the weeds will grow under. They grow under nitrate conditions, and they don't grow under the other one. That's a different way, a little bit, to explain it here. The life cycle NO3, balance NO3 and NH4, and then towards NH4. So we move from NO3 to NH4, and this is simply making this is a direct plant available nitrogen food. We know that. And the other thing that happens is we have those protozoans, and this is beneficial bacteria-eating nematodes and fungal-eating nematodes, predatory nematodes, and microarthropods. All things that are necessary to get your soil to be productive. All of this thing, we make it, is made in the compost that we started with up here. So this is why we make compost. We want to make those things, which is the complete soil food web, and with all of this different amounts inside, or more even. Okay, let's get back to this. So here's another look at the test. We can see conventional method, they simply run it like they used to run it, and then again they try the other one with the soil web approach, and you can see it is really a big reduction of weeds, and it is actually, when you see it from here, you can see the one we started with looking at is over here. I think it's over here, and it's very green compared to this thing. So this is what we get out of it in the first place, and this is in the first growing season. We reduce the input to that we don't have to spray, we don't have to give fertilizers, harrowing and plowing for the last time. So it is maybe even if we can put in annual perennial crops instead of annual crops, we will also be sowing for the last time. So it's a very beneficial way of growing things. So here it is. It is the entire soil food web, and it starts, of course, with plants. It is the plants and the photosynthesis and the energy down to the roots, which are feeding the whole soil food web. And so the sun, the plants, the roots, which are giving out what's called exudates, sugars to fungus and bacteria, which are living directly around the roots, and the nematodes are eating. And then it moves on. Here we have some nematodes that are fungal and bacterial feeders, and arthropods, protozoas, and it moves on. As we know, the whole food web goes on, and all it's doing, the plants keep it alive, and all it's doing is delivering. We could put some big arrows here back to the plants, and it's delivering food, nutrition to the plant. The plant is promoting the kind of microorganism it needs in the soil in order to mineralize the sand, silt, and clay to get all the different nutrition out of that. All the fertilizers that our plant will ever need exist in the soil, and so then it's just a matter of having the right fungus and the right bacteria and things to work the whole of this soil food web. Then the plant will get all the nutrition it needs. You don't need to fertilizer ever again if you use this method. So it continues over here. We see the birds, we see the animals, and then of course we could put a picture of people here also. So this is how it ends. So we are back with this one here: soil, plants, animals. And these animals very much have to be or can be farming animals. Ruminants are very, very good to use. And these are really, when you look at the canoes and the zebras and whatever moving across the Serengeti and other places in Africa, and they're coming in and they eat the grass in a day, it's all gone. And all the manure droppings and things are all over the place. And a few days later, birds and every sort of things are coming in to eat this thing. That is what we have to copy, this very movement of animals that are being moved, only grazing a single day, and the next day they're another place and they move on. And then comes this natural process of sort of reintroducing the manure and everything to the soil through the insects and birds and things like that. So this is very, very important. So this is actually the cycle when one can say in the conventional farming, we don't have it, as I started with saying, but we need it. So the way we can make it is simply by using compost and even biogas to put in. This I have done. I was doing it a little bit in the Kalahari, but also later in other projects. I made this thing, and it is working. It is very, very efficient way of doing farming. Yes. So this is all the microorganisms we are looking for. I just include a picture just for you to know. There's different ones: ciliates, Stegosaura, there's some fungal spores here, and flagellates. There's mycorrhiza spores here. Mycorrhiza we don't grow in compost. We have to really remember that they grow only when you have a constant plants and crops growing on your field. I mean, the so-called no-tilling or no-plowing systems where we grow. I'll talk about that later in another video. So we have the fungal spores here. So this is how, this is the whole thing we need. You can see a little bit more, see how they look. This is an amoeba cyst. This is the drawing, sort of a figure, which are taken out. And we have the ciliate cyst here, which is hugely big, I agree. 150 micrometers. This is very, very big. You'll come in, and if you have it in your microscope, you will just see a big thing like that in the middle of the slide. So it's very nice to look at. And there's another picture of an amoeba cyst here, and this is called a stalked ciliate. It hangs in the air, and here's a stellar amoeba, which is a very interesting one. Yeah, you get the picture. There are many different ones. This is just some of them to show all the things that we are looking for and making sure will be in a biocomplete compost. And the biocomplete compost can restore the soil food web in your soil in 1 to 3 years. So that means it's a whole different thing. You can have a soil that is depleted and revitalize it in a matter of 1 to 3 years if you are going to use these methods, or you are calling us to come and do it for you. Yes, so this is it. Really, the same picture again. and we have this as a very important thing. I don't have any problem with making compost that have this FB ratio, and sometimes I might be missing maybe a little bit of beneficial nematodes, then I will produce them separately. Is another technology that we have. We can produce the different things on their own, and then we add that to it. So when we bring it out on the farm in the form of compost, or in the form of compost extract or compost tea, then it will have this condition here. And we check the soil and measure. Have we achieved what we need to achieve? Have we got? Because this is the condition we need also to find in the soil in the first year after we bring this thing out. So it's a bit of a science. It's a mixture of science and art to do this thing. It certainly is a mixture of experience and art and skills to make compost. Difficult to make good compost, and you can make compost that are actually harming your soil more than anything else. Yes, I think that's what I will tell for now. So thank you very much. And you can contact me by going to Permaculture Farmers COM if you want to have a look at this one here. And here, there you will also find the video. Thank you very much.